Welcome to the Mythruna weekly live stream. This time I think we're going to go over collision avoidance for the Gayfin, the little birds that wander around. I've currently got them on a random walk, which I'll explain how that works for anybody who doesn't know about a steering API and how that stuff works. Before we get any further, let me go ahead and thank my patrons. It means a lot to me that you guys are out there supporting me, and tell your friends, etc. Looks like we've got some viewers on tonight. Feel free to ask questions as we go. And without further ado, let's go ahead and get started. So let's real quickly talk about some things I did during the week. First of all, I went back and I corrected the bird animation because it bugged me that his feet were sliding on the ground. So I did my standard trick of putting a conveyor down so that when he's walking, I could make sure that his feet moved at a consistent pace. The other thing I did, because the bird ended up moving his root bone a lot, I added an actual origin bone just to make sure, because when the physics engine gets a hold of the animation, as he moves around, his feet were sliding on the floor because his center of gravity was staying in the same place. So by doing this, I sort of orient his center of gravity over an origin, and then he moves over that. So it makes it a little better. And so when we walk in the game, when we watch him walk from the front, he won't have his feet sliding back and forth. As the body moves back and forth, his body will actually move back and forth. But the big deal was making the feet mostly line up. The way the bird's joints work, it's a little more difficult to really get that to line up. So, but it's pretty close, and certainly close enough for at this stage of the game. So let me go ahead and stop that. We'll go ahead and minimize Blender, and we can see in the game sort of what's going on. So I've got them on a random walk right now, and I've got that sound tool that we made for popping sounds down. I've got that set up to basically place birds down. They have reactive animation, which means the animation reacts to the movement that the mob is undergoing, which is why you'll see when they're falling down from the sky, they switch into the flight mode with their wings spread out and stuff. We'll see. First of all, we've got one walking around already. I left him in here. I changed their expiration to be like 2 minutes or something, so he's still walking around from before. So yeah, so he'll just randomly walk around. If I go in here, I can equip this and give him some buddies to play with. The other cool thing is if I come up here and I do like this, you can see they go into flight mode and they kind of flap their wings as they come down, which I think is cool. But one problem is that as they gather around, and certainly as we put some back in these areas, they don't really try to avoid collisions, and so you'll see they walk right into the walls, and they like this guy. He's just walking into the wall, and he just sits there. We need to give them some knowledge of the collision, so if they're heading kind of at the wall like this, he'll detect that he's about to hit the wall and turn to the side, just to make them look a little more intelligent, because now they look pretty dumb. And the other thing is, if they're face onto a wall and they've got no other solution, then they should stop and not try to keep walking forward until some other condition changes them, like the steering turns them, and that'll put them into idle mode. Right now, because they're constantly trying to walk into the wall, they never go into idle mode, because they sense the movement, the slight movement. At some point, I'm also going to have to fix the fact that every looped animation seems to have one extra frame in it. Something about the way I export it from JME. But anyway, these guys are fun to watch, and it's fun to see them get down into the corn. And of course, I'm seeing lots of network drops down in the... Oh no, that's right. I've got... I started adding the probe that's going to be necessary to... oh my gosh. I started adding the probe that's necessary for them to detect you know, what the stuff that's coming up, I'll explain what that means in a minute. And it's currently dumping a bunch of debug logging. And so when I started adding all these guys, you know, debug logging times, you know, however many, there's, it looks like 18 of them, or maybe not, 17. So let's go ahead and clean them up. Yeah. I mean, they'll clean themselves up probably. Yeah. Okay. So mostly, yeah, there they go. So we've walked around for 2 minutes, and so they've mostly cleaned themselves up. Yeah, there they go. All right, so let's first talk about what their random walk is currently doing. So we'll talk about steering systems real quick. So a steering primitive kind of says, you know, calculate the steering based on, well, it's going to get, we give it an agent movement input, which basically, you know, it's funny because last week I said I'm probably not going to treat them like they're all pressing keys like a player, but they kind of are, because it all boils down to this move vector, which XYZ says, the bird says, well, I want to turn X, or I want to walk straight forward or straight back, which is Z, or, you know, I want to move up or down, which is Y, which doesn't actually happen right now. And so then a steering primitive, you know, usually has access to the agent, you know, that's trying to move itself, and so you call calculate steering, and it'll return true if it actually modified the movement input that it was passed, and then that feeds into sort of a, in this case, a rigid body mover, which takes that input, the actual velocity of the mob relative to what it's standing on, because in Mythruna, the ground may not actually be solid ground. You might be walking on, you know, some kind of ship or, you know, boat or whatever. It says whether he's on the ground and what the current physics step is, and then from here we can take that input and factor it into a force to apply, and the turning velocity, or yeah, except the rotational velocity, or the way, the direction he's looking, which we sort of manually do without velocity. Anyway, we take that steering input, we pump it back into the rigid body to make it turn, and so then you can have some standard steering primitives. So the only two I've created so far are like a constant steering primitive that just returns the same constant thing. So if you want him to walk straight or want him to walk into a circle forever, you provide that constant. That was useful for testing because I could just have him walking around in a circle. In fact, I posted one video of that. Now the wander is sort of a standard steering primitive, and I got fancy this time. I got my I've got my Chromebook with the pen hooked up to this whiteboard, and yeah, I just managed to use my finger to accidentally draw on it. So we'll clear that real quick. There we go. All right, and I'm going to change the color back to black. Okay. So, you know, if you imagine that you've got your mob and he's heading in a certain direction, let me move this out of the way. So you think the steering primitive is going to tell which way we should turn, this way or this way. There's a standard wander primitive that projects a imaginary circle out here with a target on it, and randomly it will move that target in one direction or another every frame. So, you know, you can see this will go around the circle, and then basically every frame the mob then tries to steer, you know, towards that target, and it gives it sort of a natural appearance as the, you know, as this is slowly wanders around. It means the agent not move so erratically, because this is likely, you know, especially as it's moving through these areas here, it's likely not to change the direction very much. And even if it's moving faster through here, it's not going to make the mob look crazy or anything. So that's what sort of a steering primitive does. If you look up any steering system, they're going to have one of these wander primitives, and so you usually can say how far you want the circle away or how big you want it, because you actually could have a case where you set the circle up so that its center is really close and it actually encompasses the thing so that it'll wander backwards, or that, you know, basically anything behind the mob will be, you know, maximum turn, And so that makes it really chaotic, because as the thing is moving back around here as the target, as the target moves back around there, then the mob will just constantly be maximum turning in various directions. It makes it more random, if you want to think of it that way. So anyway, that's a steering primitive. What we're going to do today is, given our little guy, hold on, I'm not used to this whiteboard app. So given our little guy, we're going to do something similar, in the sense that in the physics engine, we're going to sort of have this probe in front of him that we're going to use to see if it intersects, a wall or, maybe another mob. And so we'll detect those contacts. In this case, I think the contact would be right here. We'll detect those contacts, and we can decide, what to do with that. Now you can see already I've given an example where it could be confusing, because he could detect this contact and then want to turn this way to turn away from it, but he's actually turning into this other one. It's a simple system because he doesn't know whether he can fit through this gap. He doesn't even know the gap's there. All he knows is that closest contact here, maybe closest contact here. And so there are different ways to do that. I think in my chicken demo, it was only the closest contact, and so it was really easy for him to get the mob or agent to get blocked into corners where they would constantly be turning back and forth. And so then there had to be some additional AI kick that decided, if I'm blocked, then I just needed to do a 180 and go somewhere else. I'm hoping that maybe keeping track of the nearest item to the left and the nearest item to the right, can have us be a little smarter. Because as he tries to go more into this gap, these collisions are going to show up closer and closer, and maybe he can decide if he can fit through or not. And the idea being that the more logic we can put down into the steering system to make them not look stupid, but then also not be problematic, then it frees up the AI to do the more high-level logic. So I like the idea. Already with the wander, they look pretty good, just wandering around of their own volition, and we'll create some steering primitives for go to the specific place, or flee from this specific target. But generally speaking, as they're wandering around, if they have some idea of the things that are in front of them, then that's usually good. If they can turn away from it and so on. So that's what I'm going to try to do today, is add these probes. And I've already added the probe, and that's what I was getting all these physics contacts. There's two other ways you could handle this. One is that the probe is actually part of the collision shapes. If you remember, if I run the rigger, and so from last week, when we set up the rig for the Geffen, and I changed this slightly, I think. No, I actually put it back the way it was. I'd given him feet at one point, but the feet were causing motion drag during certain parts of the animation. Anyway, he's got these different collision shapes. And so one way to do it would be to let the physics engine handle all of it, which we just put another big collision shape out here, maybe keyed off of the root bone of the mesh. So we put this, or maybe even the head for that matter. But you just put this big shape out here and you make it part of the collision shape. The problem is you need to then support, my physics engine doesn't yet support ghost shapes, and so it would actually prevent the bird from walking into things, having this big thing in front of him. And it would not be that big a deal to add ghost shapes, but it's really inflexible. And by being part of the collision shape of the object, then it's always part of the physics. And when it's a separate probe that we then use to query the physics engine, we can choose not to do it every frame if we want to. Maybe every 10 frames, maybe once a second. It just depends on how reactive and smart the AI should be for a particular creature. I intend to do it every frame now, but there's not a big reason to do that. You could skip frames and save yourself some time. And you could have each mob, start at different frames, so that maybe this mob starts at the frame he started at, and because this mob was created later, maybe he starts at a later frame, and then they're sort of interleaved, because if they're skipping every 5 frames, then there's no one frame where everybody is trying to run collision checks for the probe checks. So the other thing, like I said, I already started setting up the probe, which basically has, its shape, which is a sphere, but they're all n-block shapes in this particular physics engine instantiation, and it has an offset in front of, relative to the local body space, and then this orientation, which isn't really used for anything other than the fact that my particular quad D class doesn't have a so I don't have an identity constant, so I can't just use that, so I just keep it around to use. And then a query filter, which is the type of objects we want to hit. In this case, we want all of them. We want real static and real regular rigid bodies. We want everybody. And I'm not doing any tracking yet. This is the world position, calculated each time we want to use the probe based on where the agent is facing. So one thing that's missing, and so I'm just logging the contacts right now. I'm not doing anything. But one thing that's missing is visualization. As the little guy's running around, it's really useful to be able to see the probe. And so I thought maybe first I would add that so that we can, so when he decides to turn, when the bird decides to turn, we can see why, because we can visualize that, we can visualize that sphere that's hanging out in front of him, or if we end up using 2 spheres, because that's quite likely to, if you imagine, the bird walking, I'm using the mouse right now. If you imagine the bird walking and he comes up to, a meter high block, in a game like Mythruna, he should be able to fly up there. And so we could detect that, he's bumping into this, and, and if we had another probe that sits up higher, we could detect this ledge, and we could detect that, we could potentially only query this probe if we already know that we're running into something, and then the bird can figure out that he can jump up there automatically. It just is part of normal motion, and that's something that the players kind of already do. And they can sort of auto walk up those ledges, and we're just making it a little more smooth for the agents, because like in a game like Mythruna, where the terrain is usually made out of blocks, pretty much every creature you create has got to have some way of getting up 1 meter blocks at least, because otherwise that creature could not actually live in the world and not get stuck in pits or little areas of the world. If I'm going too fast on any of this, you guys feel free to chat or whatever, but just trying to give a background. So so the idea would be to visualize this, and the straightforward way would be to have some kind of, for the entity, have some kind of probe info that says, that's the component that says where the probe would be for a particular entity, and maybe you have probe entities and so on. That's all fine, and probably I will end up there, because managing those as components of the entity means that game code can decide where this probe is. For now, I've just hard-coded it in the mob, and the mob setup that decides what AI we're using, and what speed the chicken, the Gafen can walk, or whatever, will also decide where the probe goes, or maybe more than one probe. And the downside of trying to do it through entities and components is that really what we would want in the end, let me go ahead and run the game. I'm wasting a lot of time talking. Just like to give my reasons for doing things. Hopefully you guys can actually hear me talking. So in the game, actually when you run in single player, there's some debug modes that you can turn on, because the physics engine is actually, even though it's still locally networked inside, the physics engine is actually running in a way that we can access it from the client. So we kind of backdoor in so that we can create, I'll go out here and show you. So we can create these visualizations where we can see, her bounding shapes. They're a little delayed, right? Or they're a little early, because our visualization is 100 milliseconds delayed from whatever's going on this quote-unquote server. But you can see her bounding shapes as she runs around. And there's another mode, or what is it, like, yeah, so there's another mode that shows the current contacts, I think. I'm not sure why this isn't working. Oh yeah, oh, it's showing them in the wrong place, so that's bugged. It's showing that contact way over there. It's not, oh, I know it is. It's not localized for the particular style of conveyor that we're using for this terrain. But you see off in the distance here, off in the distance you can see that contact arrow. And if we were to do something like this, you can see the fact that we're running into this wall and we were running into these, you can see way over there, you can see the contacts. Because we've tapped directly into the physics engine here, that is why we can display those. And so really what I would like to do is tap into that same debug state to actually get, you know, for the birds that are wandering around, to actually get their agent and get the probe and display it as part of that, because eventually we probably also want to show the contacts, because sometimes it gets confusing when you see, you know, the probe in front of the bird and he walks close to here and he turns, but it's like, why is he turning? Because it didn't look like he should have hit it, and so on and so forth. And you can, if you can visualize the context. So that is why I think I'm going to try to tap directly into the physics debug stuff, and or do something similar to that. Now that brings its own challenges, especially since I just noticed that some of that's wrong. But it brings its own challenges because the probe info version, where you make an entity component, that's very straightforward. I know how to do it. It's like I've done it 50 times. That kind of, you know, attachment to you know, the spatial that's being viewed, the Gafin actual model, that I don't even have to think about it. And so that's what I'm thinking. I'll try to save the visualization, and we're going to have to use our imaginations to kind of see what's going on. But I'd like to actually show the steering part right away. So I want to get into the code of the probe itself, and if we find that confusing, then I'll pivot and I'll start visualizing the probe. Right now, I have set up the probe. I've hard-coded the probe to be sort of a 1 meter sphere. So if you can imagine, you know, if this is our, let me see if I can just get rid of this little, so we can imagine that if this is a meter, because the Gafin are about a meter tall. So if this is, you know, a meter from here to here, then about half a meter in front of the Gafin, you know, I don't know if I can actually grab him and move him in this. Ooh, can I undo? How do I? Oh yeah, I can. Okay, so let's say he's centered on this block, and this is, you know, a meter here. And that's his center of gravity. Then this probe is actually sitting right here, which, you know, from the top, if we imagine him from the top, again, it's kind of sitting right here. And this is why being able to visualize the probe is really useful. But I needed it to be less than a meter, because he's only a meter tall and he can walk through 1 meter high tunnels and stuff, so I don't want it to hit that. I may end up having to make it a little smaller if we start hitting the top of the, you know, the tunnels as we walk. But that's in my little test area there. That's why I have a little tunnel for them to walk through. But this seems to be a reasonable, if you think of the angles involved here, you know, this seems to be a reasonable sort of field of view for him to consider, you know, things that, you know, get in his way, and that he would want to steer out of the way. And you say, well, you know, what if there's something like right here and it's not going to steer out of the way? Well, it's not critical that he steer out of the way from that yet, but something that is right here, it would be nice if he started to steer a little early, you know, and these things kind of that get really close, you know, we would steer faster. From experience, I think that this circle probably needs to be outside of his body and not intersecting the center of gravity, but we'll work on that. That's where lots of tweaking happens and why visualization is useful, because you can see why he's turning. But I'm kind of hoping we get lucky and that this is kind of a sweet spot that at least gets the point across on what's happening. So if you use your imagination that there's going to be this sort of invisible sphere in front of the Gayfin that's we're gonna collect context for in turn. Okay. Let's see. So each frame. Let's talk about the steering. So the update loop for these mobs. Each one. We kill vertical of rotation so they don't fall over. We calculate the actual velocity and subtract the ground velocity, which is we use by detecting that they're walking on an entity or not. Then we use the probe to query the physics space, and from there we will want to use whatever the probe collected. This query context will call our probe, our contact listener, over and over again for every contact that happened to find within this shape that we passed it. And so after this is where we want to do our change steering based on probe results. And we'll factor that into the actual steering calculations, because in my thinking, if the regular steering calculation was already going to turn us away from whatever contacts we detected, then probably we let it do it at whatever speed and turn that we wanted to do. So there's going to be some kind of combination of the steering that comes out of this versus the steering that comes out of this, and it's not I was playing Jelly Rancher while listening. Nice. And so it's not clear exactly how I'll combine those. There's various approaches. This could just override that one and it's probably fine, but I just feel like that if the steering has already decided we're going to turn really fast to the right and the probe says no, we just need to turn slowly to the right, there's no reason to override those steering systems version. So probably we want a second. Let's get the overarching logic right first. So let's make a second movement input that we get from the probe. We'll treat it like a steering system in the sense that we'll let it probe calculate steering probe movement input, and except for we want to clear it. Why am I only clearing that here? Yeah, that's interesting. Probably we want to be clearing these every frame. So the reason I wrote it this way is because sometimes there's an approach where you can take a chain of steering primitives and let them each try to take a hack at it, and maybe they each provide a little different steering. But I think that I probably wanted to clear these before. Okay, so we can say we're going to do the straightforward way. Override equals false, and override equals. So if we had a probe and the probe says we should steer, then then we'll say if override, we'll do one thing, else, else if steer is not equal to null, then we'll do that steering. Override. How did I spell it right? And so we'll use that movement, but we want to movement input moved set probe and input move. So basically copy whatever So if we had any steering from the probe provided, basically it said, hey, there's something going to be in the way, we should turn right or we should turn left. Then we'll use that to just replace the movement input we would have calculated from regular steering, and we'll just override the wander that we've currently got set up. So that overall logic lets us concentrate on the probe itself. And so we can go and we now have to implement this calculate steering method, which we'll copy from steering primitive. Oops, agent driver, there we go. And somebody's got to call reset. Right, did I already do that? Yep, called probe reset. Query the contacts, so physics engine will tell us about all the contacts, which we can use to then collect information about which way we want to steer, and we'll calculate the steering. Now we just have to collect that information. We could test to see if it's working by just target, move, set. Let's say we just want to turn and move as fast as we can. And that should verify that it's actually working. Dope. Oh, I got an extra. It's up here. Yep. Okay, so back to where we want to do logic. See, I had cut and pasted this from the other demo with all the chickens running around. So I had some stuff already. The one nice thing about if I had actual ghost objects and I implemented the probe as ghost objects, we would have gotten the debug visualization for free. But it would have kind of messed up the center of gravity and stuff, so it was a complicated path to take. But now we should see that instead of random walk, if I put a chicken down, he's just going to turn right or left. I can't remember which way is which. Okay, so select our chicken placer. Place a chicken. Oh yeah, look at him go super fast around in a circle. He's doing his run walk, which involves the wings. Yep. Nice. Okay, so he's working. We can delete him. Alright. Okay, so our code is actually running. Always a good thing to test in a live stream. And so the old one just calculated the closest, and we could do that. I'm really tempted to just do that to get something working. This is what I was talking about before, is it just whichever contact was closest, left or right, it would just pick that one. So if there was these contacts, it would pick this one and try to turn this way, which is fine. That's usually right. I just kind of felt like if we tracked both, we could be a little smarter about how we turn or how fast we turn. If we know we have one really close one here, we can and another one here, we can potentially turn even faster. I don't know. But let's go with the simple way first. So we'll re-implement all the crap that I had done before. So in order to figure out what's closest, we're going to need to keep track of the minimum distance, the closest one, and I think we'd use dir to do a dot, and yeah, this turn and forward are not going to be useful. That's from the old way. Get body orientation. Yeah, so we kept track of dir for something, and that's going to be the direction in world space that our mob is facing. So every time we're reset, we're going to figure out what our new world position is, reset the minimum distance to infinity, reset the closest one to null, and reset our dir vector to whatever unit z is in our local body space. Then when we see a new contact, okay, so we do use relative as well. So temp variables, I'm relearning this code as I go, because again I cut and pasted it, and because it was a demo I didn't do a lot of commenting. So relative, we calculate the contact point relative to our body position in world space. Then, so it says facing or not depends on relative position and not our mob's facing dir. Yep, that's right. So this is not exactly accurate. We've got, wait, contact normal, relative. Yeah. So that's right. So if we have a, if in our detection, this is our mob again, and we had a contact here, its normal would look like this and its direction would look like this. And so if we dot those together, we should get a negative number because it's pointing back towards us. And so if it's not, so if it's positive, it's facing away from us, which means potentially this sphere is already so close to us, or we are inside of it, and so we are seeing a contact on the far side. There's no reason to turn away from that, and so we detect if the facing is positive, then that means the contact normal points roughly in the same direction that we're facing, close enough, and we don't bother to do anything with it. Yeah, so we ignore that one. We dot it with our relative direction. That's the direction that the mob is facing. So that'll project it down here, and we'll get a positive number if it's up here, or negative number if it's somehow behind us. But really we want things that are within a certain range of us. And this is found by trial and error. The dot product represents the cosine of, so if you've got this vector projected out here and some random point which we'll treat as another vector, and you dot those together, it basically projects them down here, and it tells you what this distance is here. And so roughly you can see that there's a circle here, and so these will, if you were to take the inverse cosine, for example, you should get the angle, and so you can figure out that, like, if it was 45 degrees, it'd be like 0.7 something, and less than that, it's going to be out here, and greater than that, it's going to be out here. For some reason, I picked less than 0.37, which means if it's somewhere way over here, like already too far to the side to matter, then, and I didn't even do anything with it. This was commented out code. So yeah, so that's the too close thing. That's what I was talking about, too close. So I'm not even doing anything with this. We'll leave it commented out. But that's what that was trying to do. It was trying to decide, if we're already, way over here, there's nothing we can do about it. We can't really turn. And probably we shouldn't use that to replace we shouldn't use this contact to replace maybe a better contact here that just happens to be a little farther away. And there's got to be some tweaking done there. Filtering contacts to find the ones that you actually turn away from is all the problem. That's the entire problem the probe has to deal with, because once you've found the contact that's best to turn away from, that's easy. But if you're still, you've got to find it first. So right now we just take the contact point, we get it relative to the body position, the distance, and if that's less than our current distance, then we track all the stuff. We track the turn, which is going to be the dot product of the closest contact relative to dir. It's part of our bookkeeping, and forward as well. Oh, so we do something with forward. So we'll calculate it. Dot products are so cheap. They're my favorite thing. They're like magic. So we'll put that up here. And that's actually the dot product of the that's actually the dot product of closest contact relative to dir, and turn is dot product of left. Yeah, okay, so what are your ranged combat tool weapon plans? In what sense? There will be some. You mean as in my immediate plans? Because I said I was going to try to do that for a Thanksgiving release, which has not happened, by the way, because I just don't feel like I have enough done to do it, and I'm about to sink a whole bunch of time into the game over December. So I'm thinking maybe just wait till New Year. But the next thing I want to get implemented regarding that is being able to swing like axes and swords and things, and to work out that mechanic on how, you know, swinging the mouse will swing the sword. And if I can get that working, you know, in theory I can. Whether the animation looks right or not, or too stupid to use, that's really where it comes down to. And so I'll either figure that out, or I'll do the fallback position, which is, you know, standard click to swing, maybe select different moves or something somehow. Anyway, product of closest contact relative to left. And apparently we do use left, so we'll have to calculate that. So we'll do that. Turn equals 0. Forward is always calculated. No, it's not. So we'll clear all of our variables. And so if we have any turn at all, then we can put that in the steering. Basically, so in the mob, he's got a dir, which is the direction he's traveling, and a left dir, which is the direction left. And so if we calculate the dot product of some point, you know, with the dir, we see how close it is to us. And if we calculate it with left, we see how close it is, you know, left or right. Positive this way, negative this way. And so if we pump that back into the steering system, and maybe we have to multiply it by -1, depending on whether left makes you go left or right. I can't remember. We pop that into the steering system, then, you know, it will make us turn. I think that we need to pop it into the steering system backwards, though, because if we're way out here, the dot's going to be higher, but we want to turn slower because it's not going to matter. Whereas if, you know, the dot is really close to us, that means it's really in front of us, and we need to turn faster. So I think it's like a 1 minus thing. I don't have that code over here, so we'll have to sort of figure it out. And I think, you know, I'll initially get it backwards anyway. Target input. Now I think when I set up the, so we ought to be able to just say if left is not equal to 0, let me do this. Oops. Otherwise return false. No long-term, like bows and arrows, Jin special weapons. I get you are laying groundwork now. Yeah, so the idea would be that you can make your own. That's the goal, right? If I can make that happen, please don't send me hate mail and dox my house if I don't get that implemented, etc. But if I can make that happen, you will design your own weapons in a workbench similar to, well, you'd make potentially components in the blueprint area, and then you'd assemble weapons and things in some kind of workbench where you give them properties, say where this is where you would typically want to hold it, and then the physics engine will like decide how that swings based on the weight of the materials you had and the weird shapes you gave it or whatever. And so when you swing it, it'll potentially behave a little differently, or you'll need more strength to control it. Those are details I have to work out. But the initial thing is to be able to click and drag and have your input translated into movement of the thing you're holding, which then, you know, factor in whatever physics I can to make that behave differently depending on how you built it. If you put all the weight at one end, you know, versus all the weight on the handle, or you balanced it well, etc., etc. And a bow and arrow will have its own sort of two-handed operation where clicking and dragging means something different, and maybe you have to click both buttons to get it to pull back or something. We'll figure out a mechanic for that, but the initial thing has got to be translating, you know, mouse input into some kind of motion. And if I can't get that to work, then I'll fall back on your standard Dungeons and Dragons combat tropes, which, you know, you click to attack somehow. Alright, so we calculate the steering, and I think if we just set left here, and we want to give it a really slow movement for now, just so we can see it work, because I think this is backwards, and it's going to sort of turn. I know for sure it will turn really fast. Well, we called it turn, actually, sorry. It'll turn really fast if it's far and really slow if it's close, so we know we already need to do that. Am I getting parched? And what I mean by that, if turn is 1 and the object is relatively far to the left, but if turn is 0.1, it's really close in our sight line. Sight line, sort of the opposite of what we want. Also negative numbers are objects to the right. I didn't happen to remember whether, I think when we had this set to 1.0, let's set that back actually. Let's retest that. I just want to see which way 1.0 made us turn rather than guess. Yeah, and the whole weapon thing, ranged weapons are the part that I still I'm a, you know, like a lot of people, you know, when I play RPGs, I'm a stealth archer. That's just my favorite thing to do. And so it's really important for me that the ranged combat game be satisfying. And I still haven't worked out how the player is going to design a bow, for example, that works. And then to make it mechanically work within whatever control scheme I come up with. But it's definitely important to me, almost more important than any of the other things. So let's see. Is the Gafen going to turn left or turn right? Let's see. Yep, turns left. Okay, so no surprise. If you set X to 1, it turns left. If you set X to -1, it will turn right. And the reason that is because, you know, the handed coordinate system we're in, if we look down Z, then positive X is left, and so if we are looking down, you know, Z, positive Z, the negative X is to the right and positive X is to the left. So that's why. Look at him just run around in little circles there. All right. We need to make him look less crazy. So back to here, we want to sort of do the opposite. So I did one extra delete here. So we want to do the opposite. Turning right is negative X, and turning left is positive X. So our real turn is going to be, first of all, 1 minus the absolute value of whatever left is, because we want it to be big when it's close, and anyway. Probably we want that to be never any bigger than 1, because that really throws the steering system out of whack. And then we want to make sure that it is the opposite. So if left, or if turn, sorry, this is turn. Oops, can't type today. It's always good So if turn was positive, then steer we want to be negative. Oops. Right. So if turn was positive, that meant the thing was to the left. That means we want to steer right, so it should go the other direction. And we want to steer really big. There's probably some math that would do this in one line, but I just don't feel like working it out. It always feels that way anyway. So anyway, we'll steer and we'll slow down. Otherwise, we don't do anything and we let random walk happen. So let's see what happens. Will this work? We can BS for another 10 minutes? Or will it be buggy and we spend some amount of time debugging that stuff? But it's funny you bring up the tools weapons thing, because that is literally the next thing on my plate. I was going to do it the same week I worked on the corn, and the corn took me too long. And then I was like, I really wanted to get mobs in. The game feels so much more alive when there's some stuff walking around. And so if I can get these guys, you know, randomly placed with some chicken coops or something, or, you know, Gafen coops, and maybe some teeny little birds that random encounter into the trees. Okay, so he's doing his random walk. And if we place a block in front of him, oops, that did not go well. There it goes. Place the block. Okay, is he going to turn away from it? Well, we can't really tell if he turned randomly, or we'll be able to tell if he never runs into anything. Oh, he turned away. Like if he never bumps a block as he's wandering around in here, that's more than random would do, right? Let's pop up here so we can see what he's doing. Okay, look, he slowed down and he went, yeah, it's working. Ha ha ha. He slows down. I'm glad I made him slow down. Yep, look at it. Ha ha. Way more intelligent. So he random walks around doing that random walk thing. And okay, he's done, because we had placed him before. Okay, so we've got this little maze now. And the other thing I want to see is if they'll avoid each other. So we'll put this guy here, and we'll let a couple of them walk. Yeah, so he slows down to get through the crack. And of course the other guy just ran away. So he's going to hit a corner. Yeah, so he slows way down and he gets in the corner and he doesn't know what to do. And now he's stuck because we're fully overriding the steering system. So that's a bug, right? That's actually worse than before. But I actually want to have this kind of contact where he's actually contacting a wall override all of the steering. And we'll do that in a minute. I should be able to place one in here and have him walk his way out. Like, look at how slow he's going. Except for the fact that he never random walks. Okay, there he goes. See, he found his way out. He looks like schizophrenic, but a little jittery there. Okay, but he found his way out. So we can work on that. Yeah, this poor guy's over here stuck, and that guy's stuck. So we got to keep him from getting stuck. And we are already getting contacts for these guys. Let's see, can I? Okay, well, we saw that contacts are being put in the wrong place, so that's not helpful. So we'll fix that, and I'll show you how. So we're already getting contacts to figure out if they're on the ground, like if they're actually touching the ground. And so one way to do this oh yeah, I got to take out that logging of the contact. That's going to kill us. So before there was ever a probe, the physics engine is already notifying us about any new contacts that come. Oh, thank you. I was just reading the comment. So any new contacts that come in, we already know, you know, we're standing on it. Best we're sliding off. So if it's an up-facing object, upness is less than up threshold. I actually think if it's less than up threshold, this is not something we are standing on. At best, we are sliding off. So yeah, we want to keep track of if we're directly sort of facing it with some sort of threshold, then we want to see. I don't think we keep a dir here. We'll just make one. We'll waste some garbage here. So our direction is going to be, again, the body. If we're going to get the body, let's get it before we need it. And we just have it already. Okay, so body orientation molt 3D unit Z. Okay, so that's our direction. And if it's in front of us, that means that the normal dir dot contact normal double front. So this number will be, so this is again like we are facing this way, the normals are facing this way. If it's something directly in front of us, then we get negative numbers. So anything from here around to here, you know, just slightly ahead of the horizontal axis would be negative relative to us, and anything, you know, from here around to here would be positive. So we don't care about the positive ones. We only care about the negative ones, and we only care about the very, very negative ones. These would be their amount of projection down our particular vector. These are really small. We care about the stuff that's really facing us. Probably, you know, square root of 2 kind of thing. You know, whatever, you know, 45, the cosine of 45. Yes, 0.71 we'll call it. So if front is less than negative 0.71, then this is a contact that we want to, we've got something in front of us, right? We'll say, or maybe we want it to be even narrower than that. Like maybe 45 is okay. Maybe 45 is okay because we'll probably miss that, and so we only care about this narrow, maybe plus or minus 15 degrees. And so if we take 90 minus 15 and then take the cosine of that, we get this really small number, 0.25. We'll just call it 0.25. So that's where the magic number 0.25 comes from. Plus or minus, what did I call it, 15 degrees? 15 degrees in front of us. I'll just set blocked to true. And what we want right now, we'll make a blocked. Related variables, private boolean. Blocked, we'll worry about what that means later. We just need to reset it when we reset all of our other stuff. Blocked equals false. And so in here, so if we're blocked, we don't want to steer at all. So let's just say, I mean, we do, but we want to pick a different steering strategy than the one we're using. So we'll just pop all this under. This is not right, but this will show that it's working. Like if we come straight onto something and we're blocked, we're just going to stop, and it should hit its idle animation at that point, which will look a little better than it's constantly walking into things. So all those guys that were stuck in the corners should at least just stop and do their idle animation. And actually the way their idle animation puts their head down, which has a collision shape, it may bump them away enough that they will walk a little bit more. We'll see. But anyway, we're about ready to wrap up anyway. Okay, so already we've got some dudes. Okay, so yeah, he didn't stop. It's disappointing. He's still trying to walk and still probing. So I have, but I guarantee we have a contact here. So there's something I've done wrong in the contact detection. Else log blocked. This will be an important event for the AI when there's actually real smarts, because that's one of the things we'll kick and we'll tell, you know, if we tried steering away from it and we still couldn't steer away from it, then okay, let's log our contact. And then and we were still blocked, then we'll let the AI know that potentially it needs to kick in something that it'll be some kind of event, right? Blocked. And just in case, let's log upness, and we'll log front. Fortunately, it's really easy to get these guys to get stuck right now. See, I don't mind stretching the stream for this, because this is exactly what I would continue doing if I killed the stream. So you guys can just stay along for the ride if you want. Okay, I think he already disappeared. No, he's still getting contacts. Okay, where's our burb? Here he is. Okay, so if we look in here, we pause this stuff going by. Yeah, it says he's blocked. So why is he bothering to steer? Oh, it's not that he's not steering. It's that he's steering incorrectly, and actually he's gone now. But so that's always, you know, a good idea to verify that your stuff's working, because I had an incorrect assumption. I assumed that maybe my math was not even getting to the detection of blocked, but it was. But the problem is that then we've still got, you know, sort of the velocity set, and there's nothing to decrease that velocity naturally very quickly anyway without steering. So we still do want to steer. So we want this to be out here, but we're going to set movement input clear. So if we're blocked, we're just going to arbitrarily, for now. Oh, wow. Wow, you are up late. I mean, that's routine for me. I stay up late all the time, but I appreciate that you're coming at this late hour. So if we're blocked, we're going to turn to the left and we're going to slow way down. Or to test what I was talking about before, we're just going to set everything to 0, so that we should stop. We should brake at that point. And then it'll stop in place, and in theory, we'll start running its idle animations. We shall see. And then we can change it to, you know, turn arbitrarily one way or the other, or we could base it on something like the probe is doing, deciding which direction that it was, and so on. But, you know, if the probe couldn't figure it out, it's probably best to just arbitrarily turn one direction or another without an AI to decide what to do. But this is why I kind of think that keeping track of the closest left and the closest right might let us do smarter things. Because, you know, if you think of Fade walking into this, if she's walking, yeah, I don't know. I just feel like the probe could detect this case. If it already knew there was going to be a contact here and a contact here, you know, it's going to keep track of the closest one, which might be this one, for example, and it, you know, and then it would try to steer us this way, and then we'll detect this one, we'll try to steer this way. But if we could detect those two contacts as we got closer, we could actually detect that those are getting closer together and that this is going to be blocked, and maybe we could do something even in the steering system to just kind of kick us around all the way, you know, 45 degrees one way or another, just to disambiguate which way we should turn. Anyway, let's leave her that way for a second. And we'll place a burb. Nope, let's let him walk into the... Oh, he's blocked. Is he blocked? Yep, blocked. Blocked, not blocked. Blocked, blocked, not blocked. Blocked, not blocked. But he's trying to work his way out. That's kind of cool, actually. But he's not ever stopping. Huh. Yeah, but AI is always like this stuff because, you know, you can see here he's blocked and he steps back a little bit and he's not blocked. You know, I would expect... Oh, the way the head collision shapes work. Yeah, that's what it is. His head is hitting, but then he steps back for a second and it's not hitting anymore. And so it allows him to walk forward a little bit. And the probe, what may be happening here is that the probe is detecting that it's right in front of him. And so arbitrarily, what if we log... Let's go ahead and delete him so we can place one down when we're done. One more thing we'll try. Now is like the endless tweaking, right? We'll try logging in here. We'll log the turn, so we can figure out what we're doing with that. Because turn not equals 0 is not good, actually. If it's 0 or anywhere close to 0, we want to do something completely different, because that means it's smack in the front of us, and we'll want to turn based on how close it is. That's what that forward value is useful for. So there's probably a thing we want to do in here where we arbitrarily sort of pick one or the other. So we would already have maxed out our turn in one direction or the other, as long as it's not 0. But in 0, we never want to detect. If there's no turn, that's not what we want. We want no forward. Forward. See, forward is, yeah, we set forward to 0, and forward will always be in front of us, always positive. So as long as forward is greater than 0, then that meant we got turn information. And regardless of, so we got some turn information because we set forward to something, which meant that there was at least one contact that was in front of us. Otherwise forward would have been 0. And if the contact was behind us, forward would have been negative. So forward greater than 0 will let us know that we at least got a contact. And no matter what, even if turn is 0, we want to do something, because that's when, you know, the nose is straight towards the wall. Yeah, contact 0 means, when turn is 0, that means that we were facing the wall directly, and we don't know which way to go. So we weren't turning at all. We were just staying there. At least that's my theory. And so we want to turn anyway, and because we've done this, we'll turn right, I think, arbitrarily, or left arbitrarily, if it's 0, something to that effect. So let's give it a try. you know, there's one thing to get him to steer out of it, and there's the other thing to make it, like, the animation look right, and that's more like averaging. But first we got to get him to get out. I'd much rather him get out and have the animation look a little glitchy than just to get stuck facing a wall with glitchy animation, right? At least eventually he would get out and wander around again. Glitchy animation's okay, glitchy movement not. Alright, so we've still got some daylight, but let's go back in time and bring up our burb tool and place a burb. Okay, what's he gonna do? Okay, so he's nosing in, and he had some arbitrary. Okay, so see, he's now jittering again, and this is because it's basically plus or minus, yeah, such a small value. He turns a little bit to the right and a little bit to the left, and yeah, so we might need to just make that range arbitrarily turn, keep a history. There's, you know, sort of math involved on how to get him out of these situations. You might be able to bump him out of it. Yeah, there we go. Oop. But it's just annoying, you know. So sometimes you need to average state over. There he goes. Sometimes you need to average state over some number of frames. Like if he's been blocked for 5 frames and suddenly isn't blocked, you know, still do the same thing that you were when he was blocked, kind of thing. But anyway, he's much smarter than he used to be. And we got, you know, we can place a bunch of these guys down, and they will tend to avoid each other as well, I think. Yeah, look at them, they slow down a little bit. Yep, these guys are gonna nose into the corner together though. Oh, look, they're slowing down. That's the other thing, is they shouldn't really slow down like that. I did that so that I would notice that they were doing something. Yep, well, they've all single filed into their own little corner here, and he'll find his way out. We'll block him in with some more that turn in. Okay, so these will all kind of group together, but they're not going to directly push on one another, which is good. Relieves the physics engine of some burden. He found his way out. Alright, so they're getting better. The other thing is, because they're completely overriding the steering, you know, with the wander behavior, they would eventually wander out. And so if I could detect that they're stuck, then I could let the regular steering run, and that might get them out of it. Yeah, he got stuck in the corner too. So that's something I'll have to deal with. But I'm not going to keep everybody on the stream because I have to stand aside and think about this and run a few examples. So anyway, thanks for joining the stream. Will there be other animals in the future? Absolutely. There will absolutely be other animals. I've got lots of them planned. There will be a cow, sheep, pig, or an animal to serve the purpose of a, you know, cow / sheep / pig. You can milk it. You can get wool from it. You know, you can fry it up for bacon. There will be other birds. There'll be some things that I want to leave as a surprise. Rideable animals, you know, some other flying things that you might not expect to fly. I've got lots of creatures planned. I like to take inspiration from the show Avatar, where they kind of mixed and matched different animals together into creative ways. Not the movie Avatar, but the Last Airbender, that one, the show. Big fan of Aang and the crew. How much can I pay for a cat animal? I will pay any amount. Well, there will probably be some kind of cat animal, because my youngest child, who's now, you know, of course 17, really likes cats. So I will definitely have dogs, because I want to get my dog. I want to get my dog into the game. We have a yellow lab, and I want to have dogs, and I want to have cats, and, you know, standard pets. But everything else is going to have some strange twist to it. So that'll be interesting. You know, like, you know, foxes with wings or something weird like that. That'll be some kind of mix of things that you might not expect, or standard things that just have some odd behaviors. But yeah, there's plenty of creatures planned, believe me. So I'll keep it in mind to make sure you can have ginger cats. No, I can't copy Avatar, right? But I can take that idea where they would mix things together, like they had turtle ducks and things like that, where they just took two arbitrary animals and mixed them together. But I get into weird territory if I start copying things directly, and Momo is definitely an iconic Avatar character that they'd be all over me, legally speaking. So there will definitely be animals. These Gayfin are just kind of the initial ones because they're random. They being farm animals, they just randomly walk around and pick up corn off the ground, and that's an easy AI to write initially. So, yeah. So, yeah, I want to have animals of different colors and stuff. So, I'll make the yellow lab first, and then turn that into different color dogs and shapes of dogs, and wolves and things of that sort. So, I think I'll just pop back over to the patrons for a second and thank them for supporting my open source development, or for whatever reason they're supporting me. And as a reminder that, well, thank you. As a reminder, you can become a patron for any amount, and if you are a developer, that gets you early access to the open source pieces of this code, which if you've ever seen any of the desert demos, or the chickens running around and stuff, that's all part of the open source or demo sections of the open source code. Eventually that'll be released, hopefully 2023. Well, definitely 2023, because if I don't get Mythruna to sort of a critical mass by 2023, then I change my direction. Either way, the open source stuff will get released. So anyway, definitely thanks guys for supporting this. It definitely helps defer my server costs, and I'm not going to be paying for Photoshop anymore, so this won't cover that anymore. But so yes, definitely thanks, and I hope to have a bunch done this week to show you next time. I'm sorry I'm not putting out a Thanksgiving release, but it's just like I'm on a roll with like 3 different things, and I just prefer to finish them rather than trying to wrap something up into a release that doesn't really do anything that the old one didn't, except for that you can place a chicken down or place corn down, and they don't do anything. So thanks for joining me. Thanks for listening to me talk as I lose my voice tonight. And I will see you guys online. If you do something cool, post a screenshot. If you're a developer, definitely post screenshots. And I'll retweet whatever you tweet at me like that. And otherwise, I will see you guys online. Follow me on Twitter, at SimSilica or at Mythruna Game, or any of the other places. Hit me up if you want a Discord invite, and you can have one. See you guys around.